Okay. So we have discussed that is the computational methods and the application of the MATLAB. Okay, so here are different problems are coming. So everyone please practice these different types of problem from the books also. And जिसके पास बुक नहीं है कोई बात नहीं, मैं ये जो बुक का जो कॉपी रहेगा वो मतलब स्कैन करके आप लोगों को गूगल क्लासरूम में पोर्टल में दे देंगे, ठीक है। तो जिसके पास बुक अभी नहीं है और मतलब लाइब्रेरी से नहीं मिला है कोई प्रॉब्लम नहीं। सो कॉपी में आप लोगों को बहुत सारे एग्जांपल मिलेगा। सो एवरीवन प्लीज प्रैक्टिस दिस प्रॉब्लम्स आल्सो। नाउ we have to do the another third method, that is partial fractions extensions method. So my whiteboard is visible, everyone? Please respond me, my whiteboard is visible? No one is responding. Am I audible?
Yes, sir.
Yes, sir.
Okay. The third is partial fractions expansion method. This is basically one of the logic. You have to learn the partial fractions in your mathematical. So how to solve the partial fractions in the different functions also for the denominator and numerator parts also. And you have to idea from the first part of control system, that is the poles and geo format. And previous classes we have to also given the particular idea for the zeros and pole, how to is calculated for the Z transform. So using these partial fractions and also zeros and pole calculations, you have to easily describe the particular partial fraction expansion method for the inverse transform. So it is parallel. Basically, this method it is parallel to the partial fractions expansion method it is used in Laplace transformation. Laplace transformation. And it is widely used in routine problems involving Z transform. This method requires that all terms in the partial fraction expansion be easily recognizable in the table. Which table? So this table is previous one. I am take the class in the physical mode in the blackboard. So this table, please remember all of you. This table it is basically very important for the Z transform methods. applicables. And also one another table it is also available, that is the different functions. I am take the previous class, that is the final value theorem, zeros value theorem, there are the polynomial functions, multiplication functions, etc. So these are the another table that is coming. I am given the table from the Google Classroom portal. So everyone please take this class notes, and this table it is very important. So using this table, we have to easily calculate this parallel function expression method. Basically, it is parallel to the operations when you have to see the Laplace transformation in the previous sections in the control systems. It is basically used for the problems of involving jet transform method when the discrete time control system, it is basically uses where the continuous time signals, that means continuous it is working. That's why I am giving you one example. That means signal is transmitted from the receiver to the transmitter. That is the receiving section to the transmit section. Or sender, it is also sending a message or signal to the receiver also. So this process, it is continue. That's what time of continue. That means you have to take a call, that is a voice call, and this voice call duration it is also 2 minutes or 3 minutes and so on. So during this timing, these signals it is transmitted from the transmit sections to the receiver sections. So in this case we have to use these functions, that is a partial fractions expansion method for the signal transmitting from the sender to the receiver section. And due to this time, there is a no losses is coming. So that's why the signal strength, we have to take the signal strength, it is very much high. So there are no objects or no objection it is coming from the when the signal is conducting from one place to the another place. So this process it is very much important for the signal transmission method. Okay. So basically, we have to take a one examples. Then you have to easily basically clear some of problem is coming. So examples, you have to given the equation, that is x of z, that is equals to a z inverse by 1 minus z inverse, numerator part and denominator. So you have to solve using the partial fractions expansions method. So now by writing z of xz as yz, we obtain the function that is a z of xz. We have to written these functions in the yz. Function is coming. You have to change this value because we have to multiply the z. That means z is also here coming from the these sections also. That means 1 by 1 minus ez inverse. Okay. Next, referring from the table, which tables are? So please everyone see the previous tables in your class notes also. That is referring to the table, that means jet transform tables, जो टेबल हम लोग क्लास में देखे थे. The inverse jet transform of yz can be obtained as follows. That is z inverse, the function is, that is the yz, that means y of k. So we have to change this equation in the polynomial functions, that is a to the power k. Hence the inverse Z transform of xz, this is equals to z inverse function of yz, is given by, that is the z inverse x of z, that is also x of k, and k is also different values changes, that is also y is equal to y into k minus 1. And here this y is equal to k minus 1, this value it is also changes to the polynomial functions also. So now we have written that is, since yk is assumed to be 0 for all k less than 0, we have, that is when xk, the value is, that is first of all y of k minus 1, that means polynomial function it is also changes a to the power k is changes to the k minus 1, that's why we have written k is equal to a to the power k minus 1. And here k is, you know that 1 2 3 dot dot n number of terms, and when xk is 0, that is also value k not is equal to less than not is equal to 0, that, sorry, k is equal, k less than equal to 0. Now this xz, we have to return x of z in the pole zero format. You know that previous classes we have to given the idea how to pole zero form we have to return for the z transform method. So first of all v0 and the power of the poles, that is the basically z to the power m. Then v1, this one z to the power m minus 1, plus then v2 z to the power m minus 2, and so on. This process is continuing. This is the before the last part. So that is the vm minus 1 into z, and last term is v to the pm. Numerator part, and then this is the basically new denominator part. You know that that is the z to the power n plus a1 z to the power n minus 1 plus a2 z to the power n minus 2, and so on. This is the before the last part, a n minus 1 z plus a. Here you can also write this condition, that is where m is less than equal to n. So here this is the basically for the zero functions, another one is the basically false functions, you know that. So we have to return these equations for the full zero format in the factors. First factor is the denominator polynomial functions to the poles and zeros also. Okay, so now we have to return these equations, that is the x of z v0 z to the power m plus v1 z to the power m minus 1 plus dot dot, that is b of m minus 1 z plus bm divided by, this is the first pole, that is z minus b1, then again z minus b2 plus dot dot n number of poles, that is the z minus bn. Okay, you know that this is the basically pole zero functions for the given equations. Now you have to easily apply this equation for the partial fractions. So when you have to written the partial functions, the output that is equal to you have to return xz by the z. This expand, that is the xz by the z of the functions, that is the xz by z This is equals to first functions we have to consider for here a1 by z minus p1, then plus a2 divided by z minus p2, and so on. Then that is an by z minus pn. This is the basically form of the partial fractions expansions or the z and poles, that is the zero and poles functions. Now here you know that this a1 a2 dot dot an, this is basically different zeros function, that is changes also. So that's why you have to return these functions, that is here I means it is changes, that is I is value, you know that 1 2 3 4 dot dot n. So the function is z minus p, this is the pi also. I means here I is changes 1 to n, that is xz by z, when the z is equal to p of I. This is the basically coefficient of the ai. It can be determined by the multiplying by both sides the last equations. Last equation is that is the previous equations also. Now we have to multiply the factor, that is a z minus pi. Pi means that is the denominator part of the different poles. Poles is changes, that is 1 to given to the number of highest pole. The functions is given, we have to return from here these functions. So each and every poles we have to easily calculated. That is also xz by z, that is c1 by z minus u1 square plus c2 by z minus p1, and so on. This process is continuing. So this is the basically coefficient of the c1 and c2 we have to calculate it from here. That is coefficient of c1 and c2 are determined from the functions. That is c1, this is equals to z minus p1 square into hz by z, this is z equals to p1. One minute. Another coefficient c2, the function is dd of ddz, because you know that when the value is changes different k is region, that is difference is coming, slightly is difference is also coming. So the difference is we have to express for ddz of z minus p1 square, that is also xz by z. This is also z is equal to. Okay, so this is the basically partial fractions method for the inverse Z transforms calculations also. Okay, using this problem, using these methods, we have to easily solve the short types of problems, this type of problem. Okay, in your books, there are lots of examples are available. Okay, so please everyone practice these problems again and again, because problem is also coming in your exams also. Is it okay, all of you?
सर और एक एग्जांपल करवा दीजिए.
Yes. Okay. Now another method, last method is coming, inversion integrals method. Number 4, that is the inversion integral method. So this is another techniques or methods for the calculation for the inverse transform method for the inversion. That is you have to calculate the different integration functions. So using these integration functions, you have to easily solve this type of inverse transform method. So mathematically, we have to written these equations. Z inverse function is given, that is a x of z. We have to written, that is x of kt. K is different values changes. X of kt, it is also same to same, that is x of k. The mathematical expression, that is 1 by 2 pi z integration to x of z, z to the power k minus 1. Okay, so here c is the basically, this is a c. C is the basically circle of the integral functions of the center, where basically c is a circle with its center at the origin. Of the z plane. Okay. So now this equation we have to written the inverse jet transform method and residue derive the using the theory of the complex variables. So now we have to given the equation number, equation 1. So equation 1 for giving the inverse jet transform in terms of residue can be derived by using theory of complex variable. So we write these equations. That is the value is x of kt is equal to x of k, that is first k1 plus k2 plus dot 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 plus k of n. K of n. That means this is basically summation of value is changes I to highest is n. That means residue of the function of xj, z to the power k minus 1 at pole z is equal to z of xj, z to the power k minus 1. So these are the basically functions for the integral method. So here you can see this I, it is changes 1 to the maximum level of the n. That means different value, that means k1, k2, k3 dot dot, that is kn. That means this where k1, k2, kn, it is basically denotes for the different residue point of the functions and different pole also, that is z1, z2 to the zms. So that's why you have to written here where a k1, k2, km denote the residues of xj z to the power k minus 1 at poles z1, z2 dot dot zn respectively. Functions of the different poles and functions. So now we have to written this equation, that is k is equal to limit z tends to zi. So the function that is z minus zi into x of z to the power k minus. This is another number, equation number, and this is the equation number 2, and this is the equation number 3. Okay, so this is the basically another method for the inversion integral method. Okay, so some of examples is given. There are lots of the examples are coming from your books also. So I am giving you one examples. The function is clearing. Okay, everyone write your own name and roll number in the chat box also. Pranav is present.
Yes, sir.
You take a screenshot, okay?
Okay, sir.
Okay, so one examples. Question is given of 10. xkt by using the inversion integral method when xz is given by the function is given xz, that is equal to z of 1 minus e to the power a t by z minus 1 into z minus e to the power a t. So that type of problems is coming in your exams. Okay, so how it is solved? So first of all, we have to written these equations into the integral patterns. That is xz of z to the power k minus 1. That is equals to the functions, that is the, this is also changes. That is 1 minus e to the power a t into z to the power k by z minus 1 into z minus e to the power minus of a t. For just wait 1 minute. For the value is changes, you know that is k is equal to 0, 1, 2, dot dot difference of value. x of z, z to the power, sorry, k minus 1. It has two simple poles, that is z is equal to z1, this is equal to 1, and z is equal to z2, that is e to the power minus z. You know that this is the basically pole in the denominator part. This is z. So first of all, pole is, that is a z minus 1. That means z is equal to 1. That's why the pole 1, that is z1 is to 1. Another one, z is equal to, that is a e to the power minus 80. That is a z2 pole. We have written here also. So now these equations we have to written into the pattern, that is x of k. This is equal to, you know that summation of range is 1 is equal to 2, y is equal to, I is equal to 1 to 2, because there are two poles is coming. First one is 1, another one is the z2, that is z1 and z2. That's why you have written I is equal to 1 to 2. So that means equation is a residue of function is, to know that 1 minus e to the power minus of at into zk, that is z to the power k, by z minus 1 into z minus e to the power minus of at pole, that is z is equal to z of I. Okay, this is not difficulty. मतलब जैसे हम लोगों को इक्वेशन को, मतलब जैसे जैसे फंक्शन दिया है उस फंक्शन में आप लोगों को पोल को कैलकुलेशन करके उसको डाल देना. So we have to written this equation, that is here two poles is coming, z1 and z2. So that's why we have to written, that is xk, that is equal to k1 plus k2 for two poles. Okay, where k1 is the residue at simple pole, that is z is equal to 1. That's why you have to written the function limit z tends to 1, that is z minus 1 into 1 minus e to the power 80 z to the power k, divided by denominator part z minus 1 z minus e to the power minus 80. This is the value, that is also coming 1. This is for the first pole calculation of k1. Then again k2, you know that that is the residue at simple pole, that is z is equal to e to the power minus 80. So that's why the limit z tends to e to the power minus of 80 function is, that is, sorry, this is z minus 1, that is z minus e to the power 80 into 1 minus e to the power 80 into z to the power k by z minus 1 into z minus e to the power 80. So you have to put the value. The value is coming minus of e to the power minus of e to the power minus of 80. Okay. So that means, hence x of kt, that is also k1 plus k2. Now we have to put the value. Value of k1 is 1 and value of k2 is minus and plus, that is a minus e to the power kt, where k is equal to changes, you know, 0 1 2 dot dot. Okay, so these are the simple types of problems is coming for your exams. Is it okay, all of you? Please respond me. Is it clear? आयुष कुमार, is it clear? सब लोग क्लास में बैठते हैं मतलब.
Yes, sir.
Yes, thank you, Afridi. Anyone, please. Okay, so everyone write your own name and roll number in the chat box also. So these are the basic process of the different inverse jet transform methods calculations. Okay, so I am given the 4 types of the methods. First of all, you know that direct division methods. Then we have to calculate the computational method. Then third one is partial fraction expansion method, and last one is inverse integral method. So these 4 methods, it is very important for the inverse jet transform method calculation. So I am uploaded the class notes. Today you also I am also try the total of the jet transform class notes and inverse jet transform class notes and different examples from your study purpose. Okay, so all of you read this module, that is jet transform. It is clearly. Again, any problems or any doubt you have also consider for the next classes for any doubt clearance. Okay. And the next class, there are another 2 topics are available from the jet transform, that is for the discrete control system. This is 1 minute. Syllabus is. We have to also conclude another 2 topics, that is a pulse transfer functions for the closed loop systems. Another one, it is also sample signal flow graph. So these 2 topics are remaining from the module 2, that is the discrete time system for the jet transform method. Okay, so these 2 topics, that is a pulse transfer functions for the closed loop system and sample signal flow graph, we have discussed in the next week also. Okay, so thanks everyone. And yes. Okay, so I am given one quiz also this week. Okay, today or tomorrow I am uploaded one quiz section from the previous module. That is, we have to module 1 and another one, that is jet transform. That is the first module. We have to consider sampling and reconstruction method. I am giving you one quiz session. I am also try today, or today is not available, so tomorrow is also available from your Google Classroom portal. Okay, so please everyone give this quiz as per yourself also. So quiz I have uploaded in the Google Classroom. Please everyone give this quiz, and this mark sheet is also recorded. It is given the future responses also. Okay, so thanks everyone. Thank you. We will continue the next classes in the next week. Another topics also, pulse transfer functions for the jet transfer. And today class notes is uploaded in the Google Classroom portal also. Everyone read this carefully.
सर गूगल क्लासरूम सर लिंक सर फिर से एक बार शेयर कर दीजिएगा ना.
कौन सा लिंक
गूगल क्लासरूम वाले से.
ओके
एडवांस आप बोला ना कि अपलोड कर देंगे उसमें.
अच्छा, गूगल क्लासरूम तो मैं लिंक तो मतलब फॉरवर्ड कर चुका हूँ, मतलब आप लोगों को व्हाट्सएप ग्रुप में. अच्छा, फिर से मैं दे दूंगा आज.
नहीं दिख रहा है.
ठीक है. ओके,
थैंक यू.